Hi everyone, my name is Rebecca Ruvinsky and I decided to record the steps of solving a Let's Practice 4 multiple choice problem, which requires you to perform math-based calculations. This problem belongs to topic 14 and it can be found in video C at the very end of it. Since the mathematical procedure was not stated in the video and only the answers were shown, I think it would be good to show you the steps that you can take to get the answers for each of the three questions. This is the first problem, and the first step is writing down a balanced equation for it. In these types of problems, you will be using the coefficient ratios to get to your answer. You have aluminum by itself plus oxygen gas, which is a diatomic element by itself, reacting together to form aluminum oxide. Now I am just indicating the charges on each element so you can understand why aluminum oxide is Al2O3. As we learned, Al has a charge of positive 3 and oxygen has a charge of negative 2. So to cancel each other out, there needs to be 2 aluminums with a total charge of positive 6 and 3 oxygens with a total charge of negative 6. We should not forget to balance the equation. There are 3 oxygens in the product. Therefore, we add a coefficient of 3 to the oxygen reactant and a coefficient of 2 to aluminum oxide. Now there are 6 oxygen atoms on both sides. There are also 4 aluminum atoms on the product side, so we add a coefficient of 4 to the aluminum reactant. Now the equation is balanced. I always like to look at the information that's provided in the video because most likely that it is important and should be used. So we have 6.50 grams of aluminum and we're converting it to moles so we can use mole ratios. From there we can say that 4 moles of aluminum can make 2 moles of aluminum oxide. And because we are looking for grams of aluminum oxide, we need to write down how many grams there are in 1 mole of it. Perform the calculations and here is your answer. Now, in the second problem, we know that 6 grams of aluminum will help create a theoretical amount of aluminum bromide. However, we are only given the actual yield created in laboratory, which is 50.3 grams. So first, we need to find the number of moles in 6 grams of aluminum. We determine it to be 0.22 moles of aluminum, and now we know that this many moles will make the theoretical yield of aluminum bromide. Here I just want to show you that the number of moles of aluminum bromide that we will be working with is the same number of moles that we found for 6 grams of aluminum. This is because their ratio is 1 to 1. Now, all there is left to do is find the number of grams in 0.22 moles of aluminum, and there's your answer. So now to solve the last problem, we first need to find the limiting reactant as well as the reactant that's in excess. So what I'm doing here is finding out how many moles of manganese the product will be created with A, 22 grams of aluminum, and B, 13 grams of manganese oxide. Because fewer moles of manganese are created with manganese oxide is the limiting reactant. Therefore, we will find aluminum in excess. Now we will use the 13 grams of manganese oxide to find the amount of grams of aluminum that will actually be used up in this reaction. I made a typo where I wrote 5.38 grams of Mn or manganese. I actually meant 5.38 grams of aluminum. So then we take the initial amount of aluminum, 22 grams, and subtract 5.38 grams from it. The result is 16.62 grams of aluminum that won't react. Again, I made a typo. I meant 17 grams of Al will be left over.